So biggest issue with this one is that people will see 0.219 and just plug it in instead of, reading the question. So it's added to what's already in there. So total of 0.799 moles. Okay. Also, if you're adding a gas, your volume should get bigger, which is what we see here. But if you put in 0.219, it wouldn't have gotten bigger. It would have gotten smaller. So there's this nice kind of balance between checking conceptually what's happening with what you're seeing mathematically. Okay, very excited we get to do the ideal gas law now. It's much easier to understand. Okay. All right, so all of these individual laws were combined together. So we've got all of these different relationships. We know volume and pressure are inversely proportional. One goes up, the other one goes down. Volume and temperature, volume and number of moles, those are directly proportional. If one goes up, the other one goes up, or if one goes down, the other one goes down, right? So what we did at this point was tied together all of those individual relationships, just realized I wrote that wrong, into a single law called the ideal gas law. Now, most of the times in the textbook, online, on the equation sheet, you're going to see it in this form, PV equals nRT. And this is really good if you are dealing with an individual state. So see how these ones are changing, right? We have a moles and a liters, and then we change the amount of moles, and we're looking for the new volume, the new liters, okay? That would be where there's a change occurring. Where you just have an individual state, now we can use PV equals N, where R is this constant. And we can have a pressure, volume, and moles and calculate a temperature. Or we can have temperature and moles and volume and calculate a pressure. So hopefully you can see that this is how it's going to be most useful when we're dealing with a chemical equation, because we need to either get in or out of moles. So as long as we have the other three variables, we can do that now. Okay, so a couple things. First of all, the value of R, 0.08206. In the exam equation sheet, there are two values of R listed. So this would be like if you had a speed that you were driving at and you have it in miles per hour and kilometers per hour. That is the same speed, it's just different units, right? Like, okay, so if a 5K is 3 miles, then kilometers per hour should be more, right? So like 50 miles an hour should be like 80 kilometers per hour. Yeah. So they're different numbers. They're the same speed. They're just different units. That's why they're different numbers, right? So that's what's going on here. R has two values based on the units. So joules is an energy unit. We use this when we do thermodynamics, which is energy associated with a chemical equation. So don't worry about that. This equation sheet's for Chem 1 and Chem 2. So I have lots of stuff on there that we don't use in Chem 1. So this is the value you're going to look at on the equation sheet. You'll do enough of these practices that I don't think you're going to get confused as long as you use it right the first couple times. You'll get familiar with it. You probably won't even have to look it up for that matter. Okay. All right. So I think what I actually want to do, I feel bad for my first class sometimes because like I get little tweaks in things and then I get to give it to you guys and they just have to suffer through me finding out the tweaks. So let's skip over the first one, the first slide here, and go to the next one. So it says, what is the temperature of 2.1 moles of gas in 35 liters at 914 torr? Okay, so we're going to be able to use the ideal gas law here. We're using PV equals nRT. T is what we're solving for. And the only thing you need to be careful here is about units. So when you look at that R value in the exam equation sheet, it lists it as 0.08206 liters, atmospheres per mole Kelvin. The units on constants are so awesome because they're telling you exactly the units you need to use for all the other variables in order for it to work out correctly. So you've got to use liters for volume. Good, we're already there. You've got to use atmospheres for pressure. Oh, we're gonna have to convert that one. So we'll do that in 1 second once we make sure we know how to do all the others. We've got to use moles, check, and our answer is gonna come out in Kelvin. Okay, so from Wednesday's class, 760 torr per atmosphere. So just like we've done any other equation, you can figure out, do I need to divide or multiply by making sure the units cancel out? So 914 torr is 1.20 atmospheres. And now we can just plug everything in and do the algebra. Very straightforward algebra, I would say. So the pressure, 1.2 atmospheres. Volume, 35 liters. Moles, 2.10. Constant, 0.08206. And temperature is what we're solving for. Okay, I've noticed that, at least in the last couple years, I don't know if they changed how you teach math or something, but you guys like to solve absolutely everything you can before you try to rearrange the equation to isolate the variable. I'm always of the opinion that like you isolate the variable first. So I would do it like this, and then I would plug everything in. You guys tend to put numbers in first, most of you. And then like even solve it out further. So like 42 and 0.172, and then divide both sides by 0.172. And get 244. However you feel most comfortable doing it, that's how you should do it. Okay, so notice we only had one of each variable. That's how I knew I could use the ideal gas law. And any time that you are using that R constant, you have to change all the units to the units that are listed with the constant. No exceptions. Okay. The other thing that's really nice about the ideal gas law is that it allows us to pull out all of those other equations that we did in the last class. We can find those through the ideal gas law. Okay, so first thing, scratch out this. It's not wrong, but I think it's easier to write it the other way. Well, in fact, it would be 1 over R, so it is wrong in a sense. Okay, so rewrite that PV over NT. I'm gonna write to correct it so that I don't hit this next fall and be like, ah, I forgot to change that. Okay, so all I did to get this form is I took the normal ideal gas law and I divided by NT on both sides. The reason why this is really nice is because I can now, because this is a constant, because PV over NT is equal to a constant, I can use this whenever I have a change. So remember how we had like P1 V1 equals P2 V2? We also had V1 over T1 equals V2 over T2. These were all individual laws that ultimately were summarized in the ideal gas law. And I will not ever give you those individual laws. So people will be like, wait a second, there's not the T and N law or something random. That's because there's a lot of different combinations that you could have here. And I don't need to give you every single one of them because they're all summarized right there. So how did I get P1 V1 equals P2 V2? I just canceled out the N and the T. Okay? If I'm using P1 V1 equals P2 V2, N and T must have been constant. And if they're constant, I don't have to include them. So I just take the PV and I set it to the PV of the new situation. Or if I want VT from up here, I cancel out P and N, and now I have V over T equals V2 over T2. So any combination of variables that you're using, you can pull them out of this relationship and just cancel out anything that doesn't change, that's constant. Okay, so let's do one of those. Cancel out this form too. So the way we just rewrote it was PV over NT, right? So I look at this. A sample of O2 occupies 375 mils, so there's a volume, 25 degrees C, a temperature, 722 torr, that's a pressure. Okay, it's giving me more volumes, temperatures, and pressures, right? That's how I know that I need to set up one of these equations as like a 1 and 2. Volume's the thing I'm looking for. I have another temperature and another pressure. I would say it's probably really useful for you guys to go through and label each V, T, P, N every time you have a problem. Not only will it help keep it straight, but it'll also just help you figure out what equation do I need to use, what form of the ideal gas law do I need to use right off the bat. So when I see that there's 2 temperatures and 2 pressures, okay, I'm immediately going to set it up as 1 and 2. What doesn't change? N doesn't change here. It's a sample of O2. They don't say anything about adding or removing gas. So I'm going to cancel that out. And I'm going to say P1 V1 over T1 equals P2 V2 over T2. So I figure out, is it a change or is it just an individual state? I take my ideal gas law and decide what equation, what form of that equation I'm going to use. We'll talk about units in a second, and then I plug in and solve, okay? So it's really about isolating, do I have an individual state or a change, and then how do I manipulate the equation to fit that circumstance. So like in this one, if I went through and labeled all of these, N, V, P, right? Really quickly, I can tell it's not a change because there's only one of each thing, and the thing that's missing is temperature. So I know I'm just going to use it as the straight equation, and temperature is what I'm solving for. When I labeled them up here, I could see really quickly that it was a change because I had multiple of each one, and I figured out what I was solving for as well. Let me just show you one more thing. So like, pretend that we had this one up here that we did at the beginning of class, but we didn't have this relationship written down for us already. We think of that form of the ideal gas law, PV over NT, and then I just include the things I want. I just include V and N. So I cancel out P and T, V1 over N1 equals V2 over N2. So it's like I'm pulling out the parts of the equation that I need to use. Okay, let's go back and solve this one. Now, units. You're going to need to decide, do you want to do your problems a little bit faster and not have to do as many conversions? Or do you not care if it takes you a little bit longer, but you don't have to remember when you have to change units and when you don't? Okay, so these are the two options. If you're worried about not being able to figure out when do I change units and when do I not, then just always convert to liters, atmospheres, moles, and Kelvin. You'll never get it wrong if you do it that way. It's just going to take you a little bit longer. If you're okay with recognizing when you can and when you don't have to, any time where you don't have to use R, so like in this instance, it was a change, so we didn't have to use R. You do not have to change the units except for temperature. You always are going to have to change the units for temperature. No exceptions on that one. So 25 is going to be 298.15 Kelvin. And if you want to know why, ask me after class. I don't need to confuse anybody. You add 273.15. That's how you get the Kelvin. So this is my T2 now, and this is my T1. Because I'm not using the R in this equation, I do not have to change the other units. It saves me some time. Maybe saves me from making a mistake in the midst of trying to do the conversion. Okay? All right, so now I'm going to go ahead and plug everything in. Pressure, 722 torr. Pressure 1. Volume 1, 375 mils. Temperature 1, 298.15. Oops. I never run out of battery this early. 10%, I'm still good. Oh my. I ended to erase some stuff. It's okay. I'll give you a chance to catch up, I guess. Okay, pressure 2, 645 torr. Volume 2 is what I'm looking for. Now keep in mind, if you're not changing units, whatever you started with for a particular variable, that's what your units are going to be for that variable now. So like I used milliliters for the volume here, so my new volume that I calculate will also be in milliliters. If you wanted to, you also could have solved this symbolically. So now I'm going to plug this in. I will go ahead and do it like in 2 steps. So I'll do the math on the left-hand side, then I'll do the math on the right-hand side, then I'll divide to isolate V2. You don't have to do it that way. You can do it all together if you want. That's just fine. Okay, how are you going to keep this straight? You're going to do a ton of practice problems, okay? So over the weekend, you're going to do as much of Chapter 5 homework as you can. I'm going to, sometime before Monday, I'm going to post practice questions for the exam that's next Friday that will cover Chapter 5 and 6. So I'll post those on Pearson. You could do those sometime next week. If you still feel like you need more practice, and how do you know if you need more practice? You should be able to do like one of each different type of problem without having to look up anything other than what's on the exam equation sheet. If you have done a lot of the problems and gotten them right, but you're like referencing the notes or maybe doing it with a classmate, that's fine. That's how you're going to start off. But you got to get to the point where you've done enough practice that you can do it without having to look at anything other than that equation sheet. Okay? All right. Let's look at how we're going to apply this now to chemical reactions. All right, so take a minute and read through the question and see if you can kind of sort through in your own head. Maybe like think about it as plan out your equation. So do a unit route to plan out how you would solve this. You don't need to actually start solving it yet, just kind of plan it out. Okay, so a lot of the times in the past, we've looked at what do I start with, right? What number and unit do I start with? What unit am I trying to go to? So I'm trying to go to a volume. It's probably going to be in liters, right? Liters or milliliters. What do I start with? Well, they gave me a temperature and a pressure. They're asking for a volume, So I don't have 2 of any one thing, right? This isn't a change. And also, I only have 2 of the 4 variables. So at this point, I cannot use PV equals nRT, right? That's the equation with gases. So I can't use it in any of the form at this point. I don't have 2 different ones, like 2 pressures or 2 temperatures or something. And I don't have enough to use this equation yet. So that must not be where I'm starting. I must not be starting with these. This would be analogous to a conversion factor. This would be like if you had a problem and it said what volume of a 0.2 molar solution, right? The 0.2 molar is your conversion factor. It's like these numbers are substituting in for that. They're what's going to get you to the volume from the moles, but you can't use them yet. So this must be where we're starting. So let's plan out our calculation. Grams of aluminum, what do we always convert to? Moles. Can't do anything until we're in moles. We've got a balanced equation. We must be going from moles of one thing to moles of another. But we can't do that until we get into moles. So we go to moles of aluminum. Now we can go to moles of hydrogen, because that's what it's asking for, right? Is moles of hydrogen gas. I'm gonna have to write the next one on the whiteboard, I think. Okay, then finally, I can go to liters, and I'm gonna do that by using PV equals nRT. Okay, so go ahead and solve this. Take a few minutes. If you don't have it in front of you, write it down real quick, because I'm going to have to unplug this so that I can charge it. All right, take a couple minutes and work through solving that, and in a couple minutes, I will write it up there. Thank you. Now don't forget, always you have to convert to Kelvin. That one's not optional. That's your constant. So this is on the equation sheet. You'll see it sometimes as 0.0821. So we'll just round it.
Why did the notes say, somewhere in the notes it said R depends on P and V?
Depends on P and V. Oh, the units of it, yeah. That's because there are two R values listed in the exam equation sheet. One of them's in joules, and the other's liter atmospheres. So yeah, use this one. Just don't worry about that 8.31, that's the other one in the equation sheet. Okay, so the first part, we did this in chapter 4, right? We did this in chapter 2, 3, when we did moles. This in chapter 4, now we're adding on this in chapter 6. I feel like at some point, I don't have an example one in here, do I? No, the next one's with, it's hard, the next one, but it's with gases exclusively. One time, I think I did on a test, a stoichiometry problem where you started with a solution, so there was like a volume and a molarity, and then you ended with a gas, so there was PV equals nRT, so it was like everything all together. It's not very nice of me. All right, clarifications on this? Did somebody else get 10.4? Good. Lots of heads nodding. That's great. Okay, let's do one more. Have 23% already. Okay, so I don't know what the deal was. I threw in, so there's like this problem. Maybe. There we go. Okay, so we're going to work this problem. This one, we don't have enough to do that yet. We haven't talked about partial pressures. We'll do that on Monday. It sounds way more complicated than it is. Okay, so chemical reaction, we're starting with a gas and ending with a gas. So I'll let you guys kind of take the lead on this. Plan out your calculation, knowing that you're going to have moles to moles in the middle. So plan out your calculation and then utilize the values given. Remember, you're going to have to convert to the proper units. And maybe let me throw this warning out there. There are 2 pressures here and 2 temperatures. You might initially think, oh, this is a change. I can just do the 1 and 2. That will not work in this instance because it's a balanced equation. These are volumes and pressures of one gas and then volumes and pressures of a different gas. You can only use the change thing, the 1 and 2, if it's the same gas, you're just changing the conditions. It is a different chemical in this instance. So I'll give you guys a couple minutes just to kind of plan out your calculation, and then I'll put a plan out there. Then a few more minutes to work it, and then I'll work it. Okay, that's crazy. I plugged it in and it got all the way up to 23, and I unplugged it and now it's down to 16. I don't know what I'm gonna do next semester when I think, I haven't looked at the class schedule. I think you guys register on like the 1st. Anyway, I think my classes are 9, 10, 11. So I don't know how my iPad's gonna get through 3 hours. Charge it in between classes, I guess. It must be because I'm recording. I bet you that's why. So it might seem like a lot initially, but it really is just doing PV equals nRT twice. You do it on the front end to get moles, and then you do it on the back end to get volume. Gave myself a whole nother page and it's still cramped.
All right, have a good weekend.
So just to like kind of offset these. First, that's not gonna work. I was gonna try and change the color. First step here, PV equals nRT to get the moles. Stoichiometry step, moles to moles. PV equals nRT again to get to volume of that number of moles. Long, but hopefully not crazy complicated. Anybody else make it that far and get 36.9? Everyone's like, nope, didn't make it that far. It's okay. All right, I'll see you guys on Monday. Try to do as much of chapter 6 homework as you can. Oh,
Did it ever go around on
no.
Monday?
No,
Okay, because I was gonna show you the notes taken out.
it's fine. I'm not that sticky about it, so.